Question 4. ABCD is a rectangle. Find the length of AC and the measures of alpha and theta. So to find the length of AC, we have options. We can either use trig functions or we can use Pythagorean theorem. So I'll show you how to do both, and you guys can decide whether or not you prefer trig or whether you prefer Pythagorean theorem. So in order to use trig, though, we have to figure out either A or theta first. So let's start off with that. If we have A up here, then that means that this is our hypotenuse. Across from alpha is the opposite, and next to alpha is the adjacent. So the two that I would have to use to figure out what A is equal to are the opposite and the adjacent. And so since we're figuring out an, I'm going to do alpha instead of theta. Since we're figuring out an angle this time, remember that we're using inverse trig functions, and opposite over adjacent is tangent. So we're going to do the inverse tangent of opposite over adjacent, 12 over 3. So we're going to put this into our calculator. You have to go to the function side, so the inverse tangent of 12 divided by 3 is 75.9, which is going to round up to 76. So the angle up here for alpha is approximately 76 degrees. 76 degrees. Now we know that the angles that are in a right triangle are complementary. So if this angle here is 76 degrees, then the angle down here would have to be 14 degrees. So now we can use that to figure out what the length of the hypotenuse is. So we can either do trig or we can do Pythagorean theorem. So the first one that I'll show you is how to use trig. So we know that this is 76 and we know that this one is 14. So it doesn't really matter which one of these two we pick. I'm just going to pick, actually I'm going to pick this one because it has theta and we're used to using our angle as theta. So we'll use this one. So that means that this is the opposite, this is the hypotenuse, and this is the adjacent. Oops, I lost my things. This is 14. This is 76, and we know that this is our right angle. So we're going to use this one again. So we have our opposite, we have our adjacent, and we have our hypotenuse, which I'm going to call x because that's our unknown. So I have to use the hypotenuse in my function because that's the one that I'm looking for. So it doesn't matter, I can use sine or I can use cosine because both of those use the hypotenuse. So we'll just use sine. So sine of theta is equal to the opposite over the hypotenuse. So here's our opposite. Sine of 14 is equal to the opposite over the hypotenuse. Remember that when x is in the denominator, you're just taking these two pieces here and you're trading places. So the x is going to be out here. X is equal to 3 divided by the sine of 14. So again, we can just tap that into the calculator. 3 divided by the sine of 14. Ooh, that is not fun. 3 divided by the sine of 14. There we go, is about 12.4. So that would mean that our hypotenuse is approximately 12.4. And that's using trig. So to use Pythagorean theorem, we do a squared plus b squared is equal to c squared. So a and b, it doesn't matter which one these are, but we know that c is the hypotenuse. So 3 squared plus 12 squared is equal to our hypotenuse squared. So 3 squared is 9. 12 squared is 144. And that's equal to c squared. So remember, keep this over here. 9 plus 144 is 153. That's equal to the hypotenuse squared. And the last step of the Pythagorean theorem every single time is to take the square root. So just so you believe me, we're going to take our calculator again. We're going to do the square root of 153. And we get about 12.4 again. So you can see that we've got 12.4, whether we do trig or whether we do Pythagorean theorem.